Welcome to College Algebra. In this lecture video, we're going to talk about section 5.4, properties and application of logarithmetic. All right. So in the previous video, we mentioned the idea of the change base formula. Okay, where when we do graphing, if the function is not in the base 10, we can actually change our base to a base 10 or the base e. All right. And I also mentioned that what happened if there were equations where I cannot make the base the same. In that case, we can actually use the change of base formula. So for example, evaluate the following logarithmic expression. So here I have log with a base of 1/4 of 0.239. So there's no way I can change this decimal into a base 2 or a base 4. So in that case, what I can do is change their bases. So if I match up with the formula, my B is 1/4, my M is 0.239. So I can rewrite this expression as log with the base 10 of my M, 0.239, over log with the base 10 of my B, 1/4. Okay, so if I cannot make the base the same, we can always use the change of base formula. And again, I can use base 10 or base e, which means I can use natural log as well. Alright, so let's put in the calculator log 0.239, close parenthesis, then divided by log of 1/4. Alright, 2 decimal places, that will give me my answer, 1.03. Now this one, it just have a 5 times in front of it when I key it in. So again, cannot make the base 8 into a 15 or 15 make into a base 8 or base 2. So if I would change the base, I'm going to have 5 times log with the base 10 of my M, which is 15, over log with the base log with the base 10 of my B, which is 8. So the 5 means 5 over 1, so that can put my 5 on the numerator. So when I type it, I can say 5 times log with the base 10 of 15, close it, then divided by log with the base 10 of 8. So that'll be 6.51. Alright, so far we have different techniques. We can change the base, we can convert log into an exponential, or we can try to make the base the same, set the exponent equal to each other. Okay, along with those techniques, there are also other types of properties of logarithm that we can actually use to help us solve in the equation. So let's say this is called the log of product. For any positive number m and n, if I have a log with the base a of m times n, then I can rewrite my expression as log with the base a of m plus log with the same base a of n. So the multiplication of my logarithm, I can rewrite them as with addition. Okay, called the log of product. Alright, for the log of quotient, okay, if I have a log with the base a of m divided by n, that division will translate into subtraction. So basically what I have is one term of logarithm, and I can split them up into 2 logarithm terms, with the subtraction for quotient, addition for the log of multiplication. Okay, so I'm basically taking one term and split them up into 2 terms. Right, so log of quotient will be log with the base a of n subtracts log with the base a of n down here. Alright, log of power. For any positive number n, if I have a log with the base a of m, if I'm raising to another exponent, all I'm going to do is bring my exponent, drop the exponent to the front, in front of the log, so that become p times log with the base a of m. So last time with this weird problem that I did with y'all, okay, I mentioned something about x squared. So what that means is this 2 by the power rule is 2 times log with the base 2 of x. Well, what I can do is using log of power backwards. That means this 2 times in front of it can go back up to the top of my x. So I actually end up with 2 times log with the base 2 of x squared. So what really canceling out here is the base 2 and log with the same base. So that leaves me with the x squared. Okay, so if I have an x squared equal to 2 to the 6th power, excuse me, if I have an x squared equal to 2 to the 6th power, which is 64, take a square root on both sides, my answer will be 8. Okay, cannot take a log of a negative number, so that's why I only use a positive 8. Alright, so what I'm going to do is show you how to use these properties here. The log of product, log of quotient, and log of power. So what we're going to do is take one term of logarithm and spread them out. Split them out into multiple terms. So I'm going to expand these following expressions as much as possible. So as far as beginning, for students who first learn this, you may not know exactly what you're looking for. So after we do a few examples, I hope these problems will be, you will find these problems not as difficult as it seems. Alright, so what we want to do here is noticing the operations. So I have one natural log term here. Natural log is a log, so it holds the same property. Alright. Fraction bar here means division. Division translates into subtraction. If I look to the top has an 11 times x to the 5th. So that multiplication allows me to split my 11 and x to the 5th separately as 2 separate terms. So starting from the top, this is going to split up into natural log of 11 plus, okay, natural log of x to the 5th power, then divided by, division here means subtract, log of y to the 7th. Okay, so now I got 3 terms of natural log. So whenever I have exponents, what I can do is bring those exponents to the front of my term, and that becomes multiplication. So that's called the log of power. So what I will end up is natural log of 11 plus 5 times natural log of x and minus 7 times natural log of y. Okay, that would be this, expanding as much as I can. All right. Now this example is very interesting because currently, okay, this is only one term, but inside the parenthesis, this problem is different from other ones because right now inside the parenthesis I got 2 terms. I actually cannot take a log with the base 5 and do a distribution. That does not, it doesn't work like that. Okay, if you look at the previous example, what's inside the parenthesis is only one term for me to split them, okay, into multiple terms. Right now I got 2 terms in here, So I got to somehow make these two terms into a one term in the parenthesis before I can split them. So it's just luckily that both of these terms can be, I can actually factor out. I can actually factor out a 25. So that will give me log with the base 5 of 25 times 25 going to 125, I think about 5 times. So if I factor out of 25 in the parenthesis, I should get 25 times 5x plus y. Okay, so now in the parenthesis of my logarithm I have a multiplication. So now I can begin to split them as log with a base 5 of 25 plus log with a base 5 of 5x plus y. Okay. And as you can recall, 25 is 5 squared. So log with the base 5 of is the same base. It can kind of cancel each other out. So that leaves me my first term as a 2. So my answer, 2 plus log with the base 5 of 5x plus y. Alright. Let's try another one. Alright, this one is a lot of stuff going on here because I have a division, so that was expanded into a subtraction. On the numerator though, there's an x squared times the square root, and inside the square root there's another multiplication between the p and the q. So let's think about this square root thing real quick. Okay, square root is the same thing as a half power. So basically p to the 7 and q to the 5th inside the square root means both those p and q is to the half power. So by applying a power rule, that gives me p to the 7/2 times q to the 5/2. Okay, so this can be rewritten as p to the 7/2 times q to the 5/2. Alright, so multiplication between the p and q, multiplication between the x squared and the square root. So that means the top alone has 2 multiplication. So that would be 2 plus signs. So that would be natural log of x squared plus, okay, this is natural log of p to the 7/2 plus natural log of q to the 5/2 minus, there's only one factors down here, or one base down here. That'll be minus natural log of e to the 5th power. Okay, so now with all these exponents on the top of my bases, I can move them all to the front of every term. So move to the front is 2 times natural log of x plus, with the 7/2 to the front, plus 7/2 natural log of p plus, with the 5/2 to the front, 5/2 times natural log of q. Alright, the last term, natural log and e will cancel out, so that would just be minus 5. Okay? Alright. I think this one is a little bit simpler because there's only one operation here, just multiplication between the 64 and the x. So if I this is only one term, so I can now split them. That will give me log with a base 8 of 64 plus log with a base x of the 5th power. Okay, now I'm going to look at the 64 as 8 squared. Alright, the base 8 and the base of the logarithm kind of cancel each other out, so that leave me with my first term as just a 2. Alright, second term, bring the exponent 5 to the front, drop it down. That will be 5 times log with the base 8, excuse me, of x. Okay. Alright. Now this one is very similar to the 125x plus the 25y. So here I got 3 terms. Can't split them unless they are one term in the parenthesis. So it just luckily, this is actually factorable. So this parenthesis, it comes with the natural log. If I factor out a 6, you know what, let's do it out here. If I factor out a 6, what's left is x squared minus 6 going to 90, I think is what, 15 times? Alright, plus 6 going to 336, 56 times. Alright, factor this again, that will give me x and x. 7, 8, give me 56. Since the last sign is positive, my 2 signs are the same, and both of them got to be negative. So they can add, so my inner and outer can add up to be negative 15. So inside this parenthesis will be natural log of 6 times x minus 7 times x minus 8. Alright, so now I got multiplication between my 3 factors, so now I can split them. So that gives me natural log of 6 plus natural log of x minus 7. I'm going to put this in the parentheses since it's 2 terms. Plus, this is 2 terms in there, natural log of x minus 8. Okay, that would be my answer. Alright, vice versa. This is expanding it. Now what I'm going to do is condense these expressions back to a single logarithm. Okay, so for example, this subtraction sign, okay, condensed back to a single logarithm will be division. So that means this is going to give me a natural log of, I'm going to put a parenthesis, z on top over 19y. Okay, and that's as simplified as you can make them. Alright, now with other examples, it all depends. Okay, condensed back to a single logarithm. So what I'm looking at right now is the plus and minus signs outside the parentheses. So that subtracting sign means dividing. So that means whatever's in the front of this, whatever is in my first term here, got to go on the top. So this is going to be log with a base 3 of x squared plus ax plus 15 over x plus 3. Okay, so I'm purposely not writing all these guys together in a different parenthesis because I'm about to insert more. So, you know, on the homework they will have certain parentheses in place. Every time when you write a log or natural log, whatever come after that is all together. Therefore, it makes everything into one big term. Alright, I'm going to factor the top. I think this is factorable. So this is going to give me log with a base 3 of 15, 3 and 5. So that's going to be plus 3 and plus 5 over x plus 3 in the denominator cannot be factored other than 1. So if I put them in the parenthesis, it demonstrates a factor of 1. So now I got one term on top over one term in the bottom. The plus 3 can cancel out. So my final answer would just be log with the base 3 of x plus 5. Okay, I'm going to put this x plus 5 in the parenthesis. Okay, so this parenthesis represents every time I roll a log, it'll attach with the parenthesis. Okay. Alright, this one is a bit tricky. It can be a little bit tricky. Alright, first thing first, I got numbers in front of my log term, so those go backwards means it go back on the exponents. Okay, so keep that in mind. The subtraction sign here, okay, is telling me dividing. So when this 5 go back on the exponent on the outside of x over 2, that will be to the 5th power. So if I apply my power rule, that will be x to the 5th over 2 to the 5th. Okay, same thing with this 4. Once this 4 go up here, use a power rule. Okay, that would be 1 to the 4th over y to the 4th. So when I write my single logarithm, okay, if I can see certain things ahead of time, I can just write this as a log with the base 4 of x to the 5th over 2 to the 5th, which I know 2 to the 5th is going to be 32. So I'm going to write 32. Okay, over 1 to the 4th. Once this hop up, power rule, that will be 1 to the 4th is 1 over y to the 4th. Okay. Move over here a little bit. Okay. Alright, so now to continue to simplify, remember now this is taking the top divided by the bottom. So if I take the x to the 5th on top over 32 divided by 1 over y to the 4. Division of a fraction tell me I will times the reciprocal. So my answer would just be log with the base 4 of, who's on top? X to the 5th times y to the 4th over 32. Okay. Alright, so that will be my final answer. Now this problem, during the review of exponents, I mentioned when you have plus and minus signs on the exponents, okay, it can be expressed as product rule or quotient rules. Okay, so there are different ways to do this particular problem. What I mean by that is with the signs right here. Okay, so I got 3 terms up here. That subtraction sign means quotient rule for the exponent. The plus sign means product rule. But I'm actually gonna look at the 2 terms with the natural log together. Okay, with the 6 up here. Okay, if I with a 6 in front of my natural log, that means if I go backwards, that 6 will go back on the exponent. So that means I should have e to the 8th power minus, okay, and at the same time though, once I bring this up here, between these last 2 terms, I'm going to factor out a -1. So I will keep that subtraction sign the same. Natural log, okay, of x to the 6. If I factor out a -1 between the last 2 terms, this plus sign will become minus natural log of y. Okay, so this subtraction sign okay, according to the exponent rule, means dividing the top exponent minus the bottom exponent. So that means my e to the 8 is now going to divide by, alright, e. So where does e come from? This e come from what? For example, if I got, let me do it this way. If I got a to the m over a to the n, okay, that become a to the m minus n. So this minus sign, that minus sign become division. Okay, this a single base a split into two bases for the quotient rule. That's why I got base e on top, and I also gonna have base e in the bottom, because these two terms up here shares the same base. So now that will be e to the natural log of x to the 6th power. Okay. Alright, let me go ahead and do this. See that minus natural log of y. And that minus sign right there, okay, these two terms in the parenthesis with a minus sign there, that means this two can be split again. So if I will split these two, that means that will be e, excuse me, these two natural log with a subtraction, that means I can rewrite this top. Let me just erase this. You know what, let me do it this way. Okay, I'm gonna write it this way for right now. Okay, so I got e to the a on top over, alright, so natural log minus natural log. Okay, quotient rule tell me that I can write these two as a single logarithm. So that will be e to the natural log of x to the 6 over y. Okay, subtraction between two natural log, we can condense them back to a single logarithm. Alright, natural log and e will cancel out. So the bottom should just be left with x to the 6 over y. The top still have e to the 8. So if I take e to the 8 divided by this fraction, that means we will times the reciprocal. So that means these x to the 6 over y will be flipped. So when this y flip, it's going to be e to the 8 times the reciprocal, which is y. Dividing by this means times reciprocal, times y over x to the 6. So that actually flip my y to the top, x to the bottom, but my e to the 8 is still on top. That's why my final answer is e to the 8 times y over x to the 6th power. Okay, so a lot of division, exponent rule all come in place. Alright, this one looked kind of bad, but it's actually not as bad. So I see a plus sign, so that means I will multiply. Alright, I see this number in the front, that will bring back up to the exponent. Okay, subtraction sign here means dividing. So all the log has the same base, so that will be a single logarithm. Okay, if I bring this back up here on the outside the parenthesis, that's a 4th power. Now 4th power out here, use a power rule, that will give me x to the 12, y to the 8 times, okay, this 2 back up here, apply power rule, 1 squared is 1 over x squared is x squared. Subtraction here means dividing, okay, y to the 5th. Okay, so now this is not bad. 12 power canceled out with x squared. So give me log of x to the 10 power. All right. Y to the 8 over y to the 5th canceled out. That should be y to the 3rd left. So that's my final answer. All right. So a little bit of property. Okay. Of log of product, log of quotient, and log of power. So with all these techniques being introduced, now we are equipped to solve other types of exponential equation and logarithmic equations. All right, that will conclude this video. Thank you for